All right, let's step things up a notch where we might have to apply not only our knowledge of how to differentiate logarithms or exponentials or other types of functions like polynomials, but we might have to apply chain rule or product rule to the questions we're about to look at. So let's look at this first example here and we'll set it up. So we're using function notation, e to the x, and this is times log of x. So we've got two functions being multiplied together. So in this situation, we need to apply the product rule. So let's start with identifying u is e to the x. So this is u and this is v. V is log of x to a base of e. So our derivative of e to the x, which is u dash, is simply e to the x, and our derivative of log x is 1 on x, because it's the derivative of this function, which is 1, over the function. Now applying the product rule, y dash is equal to u dash v plus v dash u. U dash is e to the x times v, which is log of x to a base of e, plus v dash 1 on x times u, which is e to the x. Okay, we could take out our common factor here, which is e to the x, and then we'd have in brackets log of x plus 1 on x. And that's our final result for that question here. Okay, let's have a look at this question. It's already set up for us in the form of an equation, so we can go ahead and start to differentiate. But we might consider changing this that's currently in surd form into fractional index form. So let's rewrite this before we differentiate. And remember, when you take the square root of something, it's the same as taking it to the power of a half. So we'll rewrite that as 5x plus 2 all to the power of a half. Now we can go ahead and differentiate. So we'll use dy by dx notation. And remember, when we're going to differentiate, it's the log of this function. So that result, remember, is the derivative of the function over the function. So let's differentiate this function. So using our knowledge of the chain rule, bring the half to the front, 5x plus 2, take 1 off the indices, so that becomes to the power of a negative a half, and then times by the derivative of what's in brackets, which in this case is 5. All over our original function, which was 5x plus 2 to the power of a half. Now, because the question was given to us in this surd form, let's rewrite our final answer using the same notation and see if we can tidy up the top a little bit. So we've got this 5 times a half, so let's make that 5 over 2. And then we've got here, that's multiplied by 5x plus 2 to the power of a half, negative a half. So that's all our numerator, and then we're going to divide it by our denominator, which is 5x plus 2 to the power of a half. Now remember, we can rewrite this in surd form. So the 5 will stay on the top, the 2 will go to the denominator, and we can push all of this to the bottom and rewrite it as 5x plus 2 and the square root of that. When we're dividing it, it's the same as multiplying it by its reciprocal. And the reciprocal of this would be 1 over 5x plus 2 to the power of a half, which is the same as taking the square root of 5x plus 2. So now you'll notice we can multiply straight across our numerators, which becomes 5. 2 times 1, which is 2, and we've got root 5x plus 2 times root 5x plus 2, which will ultimately give us just 5x plus 2. And that's our final answer. Now, we possibly could have done this question a whole lot easier if back here you'd recognise that when you've got a logarithm raised to a power, remember you can bring that power to the front. So let's have a look at how we could have done this question differently. So back up here, I could have written it as y equals a half log of or 5x plus 2. Now when I go to differentiate that, I end up with y dash equals a half times the derivative of the function, which is 5, over the function, which is 5x plus 2, and I end up with 5 over 2 times 5x plus 2. I end up with the same result, but it's much easier if you can use your log laws early to simplify things.